Hey everyone! Welcome back to ZoomInData. This is episode 4 of our KQL Concepts Deep Dive series. Today we're going inside the Azure Data Explorer engine to see how it really works under the hood, specifically the ingestion path versus the query path. If you missed the previous episodes on columnar storage or pipeline thinking, they're worth a quick watch. Let's jump right in. Quick roadmap for today. We'll start with a quick overview of what the ADX engine actually is, then break down the two main paths, ingestion and query, step by step. We'll see how data gets ingested, how queries are executed, how the two paths connect behind the scenes, some key internal concepts like extents, caching, and materialization, and why understanding this gives you a real edge in interviews. Ready? Let's go! So what is the Azure Data Explorer engine at its core? It's a distributed, columnar analytics engine designed specifically for massive telemetry and log data. It can ingest data in real time while still delivering sub-second queries on petabytes. One of its smartest designs is separating compute from storage. You can scale ingestion and querying independently. Everything happens through two main paths: the ingestion path, which is all about getting data in quickly and reliably, and the query path, which is about running your KQL queries as fast as possible. Let's walk through the ingestion path. Data arrives either streaming, like from event hubs or IoT, or in batches, files, queues. First, it's buffered and validated, then parsed and mapped to your table schema, handling JSON, CSV, whatever. Next, it's batched into immutable units called extents. Think of them as mini tables that never change once written. Finally, each extent gets indexed and compressed before going to persistent storage, Azure Blob. The whole process is append only, no locking, no transactions, which lets ADX ingest at insane speeds without slowing down queries. Hey everyone, check out this simple horizontal flow diagram. It shows exactly how data gets into Azure Data Explorer. It starts on the left with data sources, streaming from Kafka, IoT, APIS, or batch files. Then it moves to buffer and validate to make sure everything is clean. Next, parse and map turns raw JSON or CSV into structured columns matching your table schema. After that, data gets batched into small, immutable blocks called extents. Look at those little sealed boxes. Once created, they never change. Finally, each extent is indexed and compressed for speed, then stored in blob storage on the right. The whole path is append only and super fast. No locking, no waiting. So fresh data hits storage quickly while queries keep running smoothly. That's the ingestion magic. Now the query path. You submit a KQL query. It gets parsed and optimized first. The optimizer pushes filters down early, prunes unnecessary extents, and builds a distributed execution plan. The engine then reads only the relevant extents from storage. Thanks to columnar layout, it skips columns and even entire extents that don't match. Processing happens in memory, filters, aggregations, joins, all distributed across nodes. Finally, partial results are aggregated and sent back to you. The whole thing is optimized for columnar reads and early data reduction. How the two paths work together. Ingestion keeps creating new immutable extents without touching existing ones. Queries read from those extents without any write locks, no interference. Freshly ingested data goes into the hot cache, in memory. Older but recent data into warm cache, SSD, and everything else stays in cold blob storage. Because extents are immutable and metadata tracks them, new data becomes queryable almost immediately, often in seconds, while old queries keep running smoothly. No blocking, no downtime. Hey everyone, take a look at this vertical split diagram. It perfectly shows how ingestion and queries work together in ADX without stepping on each other. On the left side, the ingestion path flows downward. Data comes in, gets turned into immutable extents, then layered into hot, fast RAM, warm, SSD, and cold, blob, storage. On the right, the query path flows upward. Your KQL query pulls from those same layers, starting with hot for newest data, warm for recent, cold for old, and ends with your result. Right in the middle is the bridge, metadata and caching. It tracks every extent, knows where data lives, and decides what to pull from which layer so queries stay lightning fast and ingestion never blocks. This separation and smart middle layer is why ADX can ingest real-time while queries fly. No interference, just smooth teamwork. A few key internals to know. Extents are the building blocks. Immutable, compressed, indexed mini tables that hold the actual data. Caching layers, hot in RAM for newest data, warm on SSD for recent, cold in blob for everything else. Make sure queries hit the fastest possible storage. Materialized views pre-compute common aggregations so repeated queries are instant. Background processes auto-merge small extents and optimize indexes without interrupting work. And everything is distributed. You can scale ingestion nodes and query nodes separately as needed. Why does all this matter? Because this architecture gives ADX incredible performance. Append only means no locking during ingestion. Immutable extents allow safe concurrent reads and writes, and selective extent pruning combined with columnar reads means queries skip huge amounts of irrelevant data. In interviews, especially Azure Data Engineer or Sentinel roles, they often ask, explain the ingestion versus query path in ADX. How does it achieve high ingestion rates and sub-second queries at the same time? Or, what are extents and why are they immutable? Knowing this shows you understand the engine, not just the language. Hey everyone, check out this split view diagram. It captures the whole magic of ADX in one picture. On the left, the ingestion path shoots data in fast. Think real-time logs or telemetry pouring into the engine with that big incoming arrow. On the right, the query path shoots results out fast. Your KQL query gets answered quickly with that outgoing arrow. Right in the center is the bridge, the ADX engine powered by extents plus caching. Extents keep data immutable and organized. Caching keeps hot data in RAM or SSD for lightning speed. Together they make sure ingestion never slows down queries and queries never block ingestion. The speed and scalability icons show why this works so well. Fast writes on one side, fast reads on the other, all balanced perfectly. That's how ADX handles massive scale without breaking a sweat. To wrap up, Azure Data Explorer separates ingestion and query paths so they don't interfere. Ingestion is append only, creating immutable extents that go into storage. Queries pass, optimize, and read only what's needed from those extents in a distributed way. Extents being immutable enables safe concurrency, caching layers keep hot data fast, and materialization preps common results. This is the core reason ADX can ingest real-time while querying petabytes in seconds. Smart internals, not magic. That's episode 4 wrapped. Thanks for hanging out with me on ZoomInData. Next in episode 5, Data Types and Dynamic Nature, we'll explore how KQL handles flexible types like dynamic and arrays, the conceptual trade-offs, and why it's perfect for semi-structured logs. Homework to lock this in. Explain out loud. How does ADX manage to ingest data in real time without slowing down queries? Think of a real scenario where hot, warm, and cold caching layers would make a big difference. Answer this interview classic. What are extents in ADX and why are they immutable? If this was helpful, like the video, share it with your friends prepping for Azure jobs, subscribe for episode 5, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those internals. Bye for now.